In this video, we are going to see the difference between equally spaced and not equally spaced data. Let's look at the data using two variables x, y, and we have 2, 4, 6, 8. Y values are -1, 0, 3, 7. Now we have to decide if this data involving x values and y values is equally spaced or not equally spaced. To decide if your data is equally spaced or not equally spaced, just look at the x values and see what is the difference between every two consecutive x values. The difference between first x value and the second x value. And how do you calculate the difference? Second value minus first. 4 minus 2, it is 2. The difference between 6 and 4. 6 minus 4, it is 2. The difference between the next two values, which are 6 and 8. So you calculate the difference second minus first. 8 minus 6, which is 2. So you can see that all along this data, the difference between every two consecutive values is 2. So here we are going to call H as class step, or the difference between every two consecutive values, and here it is 2. So if for the whole data, the difference between every two consecutive values, every two consecutive x values is same, you will call that data equally spaced. You don't concern yourself with how the y values are given. So another thing that you have to pay attention is, let's write the same data, x and y. Here you have 2, 4, 6, 8. This data is equally spaced, and now you know that h is 2 and y values are -1, 0, 3, 7. Now let's name this data. Let's put the notations. So first x value will be called x0, next value will be called x1, next x2, next x3. And you know that this data is equally spaced. The corresponding y values are y0, y1, y2, y3. Now please see this. How did you get from x0 to x1? So how do you get from 2 to 4? You get to 4 by adding 2 in the previous x. What I am saying is, how do you get to x1, which is 4? So you have x0 and you add h into this. x0 was 2 and h is 2. 2 plus 2, it is 4, which is x1. Next x, which is x2. How do you get this? So in the previous value of x, which is x0 plus h, you add h. Since the difference between every two consecutive x values is h, so you keep on adding h into the previous x values to get the next x value. So x2 is equal to x0 plus 2h. Now how do you get x3? So in the previous x value, which is x2, which is x0 plus 2h, you add an h, which becomes x0 plus 3h. So what you are seeing here is, if your data is equally spaced and the first x value is x0 and h is the difference between every two consecutive x values, then the equally spaced data follows this pattern. x0, the next value is obtained by adding h into this previous x0, and next value is obtained by adding h into the previous value. Previous value is x0 plus h, and now we add another h, and the next value will be the previous value, which is now x0 plus h, and you add one more h. So you can see that the first value is x0. The next value is x1, which can now be written as x0 plus h. The next value is x0 plus 2h, but it is also x2, because see, first you have x0, then x1, and then x2. Next value could be written as x0 plus 3h, but after x2 this must be x3. So what we are seeing here is, if your data is equally spaced, x0 is the first x value, x1 is the next x value, but it is obtained by adding h into x0. x2 is obtained using this formula, x0 plus 2h. x3 is obtained as x0 plus 3h. So we can write in general, x4 could be written as x0 plus 4h if your data involves x4. Same way, x5 could be written as x0 plus 5h. So this pattern is followed only in an equally spaced data. So following this pattern, we will remember xn will always be written as x0 plus nh, but only for equally spaced data. Okay, so let's look at another example of the data. Here we have x as 1, 2, 3, 5, and y values are -1, 0, 1, 2. So we have to decide if this data is equally spaced or not. The difference between the first two consecutive x values is 1. So you always calculate the difference, second value minus first. 2 minus 1. 3 minus 2, it is 1. 5 minus 3, it is 2. Since h is not same here, that is the difference between every two consecutive x values all along this data is not same. So this data is not equally spaced. Now let's look at this data. Now we have to decide if this data is equally spaced or not. Don't look at y. Y could be in any form. Y could be any number. But let's decide if this data is equally spaced looking at the x values. So first you calculate the consecutive difference between every two consecutive x values. And difference is calculated second minus first value. Not as 3 minus 5, but 5 minus 3. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. So yes, this data is equally spaced. So this is how we will decide, looking at the data, if it is equally spaced or not equally spaced. Now another important thing is, if we have our data, we can immediately see that this data is equally spaced and h here is 1. That is the difference between every two consecutive x values. 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. So if we have to write a polynomial for this 4 points data, we will use either forward difference form of Newton's polynomial or backward difference form of Newton's polynomial. If your data is equally spaced and you have to write a polynomial for this data, then either you use forward difference form of Newton's polynomial or backward difference form of Newton's polynomial. We will further talk about this in the next video. But if you have a data, let's say in the form, here Let's check if this data is equally spaced or not. 3 minus 1, 2. 5 minus 3, 2. 11 minus 5, 6. So this data is not equally spaced. So if you have to write a polynomial for this not equally spaced data, you will use divided difference form of Newton's polynomial. In the next videos, we will talk about how to write the forward operator form of polynomial, the backward operator form of polynomial, and divided difference operator form of polynomial for equally spaced or not equally spaced data sets.